Hey there, Cognitive Explorers. My name is Parker Merritt from IBM Data and AI, and today I'm going to walk you through how you can build an automated AI pipeline using data from any cloud of your choosing, all without writing a single line of code. Now, all of this is made possible through IBM's Cloud Pak for Data, a cutting-edge new analytics platform powered by Kubernetes and Red Hat OpenShift. With Cloud Pak for Data, you can access, organize, govern, and analyze all of your business's data, no matter where it's located. In this example, we're going to connect our Cloud Pak instance to an S3 storage bucket on AWS and use that data to develop and deploy a predictive model. Let's get started. First, log into the Cloud Pak for Data web client. If you don't currently have access to a Cloud Pak for Data instance, you can request a free trial environment with Cloud Pak Experiences found in the link in the description. Once you're signed in, take a moment to explore the main dashboard. Here, users can configure a custom interface with various metrics related to the number of data assets, governance rules, business terms, and more. Once you're finished exploring the main dashboard, click on the menu icon in the top left corner, then click the Projects tab. Projects are how Cloud Pak for Data organizes collections of related resources. These resources might include imported datasets, machine learning models, Jupyter notebooks, and if you're the creator of the project, you can also manage which collaborators have access to these assets. After navigating to the Projects tab, click the New Project button. Then, select Create an Empty Project. Give your project a name and an optional description. Note that you can also integrate your project with the version control software Git. Integrating with Git allows you to sync your project with a remote repository, for example, GitHub, which is useful in a number of ways. From supporting collaboration with the broader data science community, to helping you more easily back up and share your project's assets, Git integration is a great feature for meeting all kinds of developer needs. Once you've decided on your project's name, description, and settings, click Create. Decide whether you'd like to take an optional tour of the interface, then you'll see the project overview page. Click Assets on the menu bar to see the resources contained in your project. Now it's time to connect to our AWS S3 bucket. Click Add to Project, then Connection. Take a moment to check out all of the different options for connected data sources. 85% of organizations already operate in a multi-cloud environment, so ensuring connectivity across these disparate data sources is a core part of Cloud Pak's value proposition. Once you've reviewed the many data source connection options available, click Amazon S3. Again, give your new connection a name and an optional description. Also, fill in the name of your S3 bucket. Be sure to enter it exactly as it appears on AWS. To complete this final step in connecting our cloud environments, we'll have to switch over to the AWS Management Console. Go ahead and open up a new browser window and navigate to the Amazon Web Services homepage. Once you're logged into the AWS Management Console, click on your username at the top right corner, then on My Security Credentials. Open up the Access Key tab, then click Create Access Key. Click to reveal your profile's access keys and copy and paste them somewhere safe for later use. Fill in the access key and secret key fields for your S3 bucket connection. Next, click Test to ensure your connection was successful. Finally, click to create your new connection. Note that your AWS S3 connection now appears under your project's list of data assets. Now it's time to import the dataset contained in your S3 bucket. Click Add to Project, then Connected Data. Select your AWS S3 connection as the source of your dataset. Choose the CSV file you'd like to build a predictive model with. After selecting your connection source, you'll be prompted to give your data asset a name and, optionally, a description. Then, click Create. Now, the dataset located in your Amazon S3 bucket is available in your list of data assets, ready for use in a collaborative analytics project. At this point, you've successfully added a multi-cloud data asset to your project. However, you still need to clean your data. For many data scientists, 80% of their time is spent on data preparation, tasks like data cleaning and reorganization. Cloud Pak's Data Refinery tool will help us streamline and accelerate this process. Hover over the Actions icon next to your connected dataset, click Refine from the drop-down menu. On the right-hand side of the Data Refinery interface, you'll see the Steps window. As you clean your data, the various transformation operations applied will appear in order here. On the left side of the interface, click the Profile tab, where you'll see various summary statistics of your dataset. These statistics are useful for performing an exploratory analysis of your data, which is an important first step in any data science project. Unfortunately, our columns currently have the wrong data type, so for now, these statistics aren't very meaningful. Let's click back over to the Data tab to start transforming and cleaning our dataset. At the top left corner of the interface, click to open the Operations menu. Then, click Convert Column Type. Select each column and apply the corrected data type. Be sure to differentiate between decimals and integers as you progress through each column. Double-check the corrected column types one last time, then click Apply. Review your corrected dataset and note that your column type conversions now appear under the Steps tab on the right side of the interface. Once you're satisfied with your list of data transformations, click the clock icon on the top menu. Click Save and Create Job. Give your data refinery job a name and an optional description. When you're done reviewing the settings, click Create and Run. Within a few moments, Data Refinery will begin performing your selected data transformations on the target CSV file. Once the job status changes from running to completed, navigate back to your project overview page. Note that your project now contains your completed data refinery flow, which includes a record of the data transformations performed in your job. You'll also see the cleaned CSV file in your project's list of data assets. Now that our data is cleaned, it's time to automate our AI pipeline. Click Add to Project, then find the Auto AI Experiment option. Auto AI is Cloud Pak for Data's graphical, intuitive AI automation tool. The tool does all the work for you, helping you build and deploy a machine learning model in just minutes. And again, all without writing a single line of code. Select Auto AI from the list of options. Give your experiment a name and an optional description. Finally, click Create to begin building your Auto AI experiment. First, we'll need to add a data source to train your AI model. Click Select from Project, then choose your clean dataset. Next, you'll be prompted to choose a target variable for your prediction model. In this example, we'll be training our model to predict the compressive strength column of our concrete dataset. By default, your Auto AI experiment will use a regression algorithm to predict your target variable, optimized through the minimization of a root mean square error. Let's check out the experiment settings page to see some of the other algorithms and optimization metrics available. Note that you can modify how your Auto AI experiment splits your dataset for training and testing. There are also several other options for prediction type, in addition to a variety of metrics for measuring the performance of your model. Let's leave the default settings for now. Finally, click Run Experiment to have Auto AI begin building your model. As Auto AI analyzes your dataset, it will iterate through various data transformations, automatically picking the best algorithms and parameters for the purpose of your project. As it progresses, the tool will automatically generate candidate model pipelines, each customized for your specific predictive modeling problem. Within just a few minutes, you'll have an extensive list of potential pipelines, ranked according to your chosen optimization metric. Once your Auto AI experiment is finished running, scroll down to the pipeline leaderboard to compare the performance of each model. According to this list, Pipeline 4 had the lowest root mean square error, so let's choose this one to save as a model. Give your new model a name and a description, then click Save. Now, you should see a success notification indicating your model is available as a project asset. Click the link in the notification. Here, you'll see various details about your new model, including the input data types used in your training set. Let's make your model available for use by developers in your enterprise. Click Promote to Deployment Space. If you haven't yet associated your project with its own deployment space, you'll need to create one first. Click Associate Deployment Space. Give your deployment space a name and an optional description, then click Associate. Now you'll be able to promote your model. Click again on Promote to Deployment Space, and in a few moments you'll see a success notification. Click the link to navigate to your deployment space. Here, you'll see your new model staged and ready for deployment. Hover over the Actions icon and click Deploy from the drop-down menu. Give your deployment a name and an optional description, then click Create. In a few minutes, you'll see your deployment status change from In Progress to Deployed. Click on the deployment's name to view more details.
At the top of the page, you'll see a RESTful API endpoint, which developers can use to interact with your model. You'll also see various example code snippets in some of the most popular programming languages to help you get started. Click over to the Test tab to try out your model. You can test your model by entering a few sample data points, either in an easy-to-use form or in JSON format. Choose a row of data points from your CSV file to test your model's predictive capabilities. Compare the model's prediction with your dataset's true value. If the results are satisfactory, your model is ready for production use.
And there you have it. Within just minutes, you've successfully built and deployed a multi-cloud AI model for use within your enterprise. By leveraging a collaborative, unified analytics platform, users can accelerate their project's time to value, securely manage their data, and enable continuous AI innovation. For more on how Cloud Pak for Data can accelerate your journey to AI, feel free to reach out to me personally at parker.merritt@ibm.com, and be sure to keep up with IBM on all your favorite social media. Thanks for watching.